If I gave you $1 and told you that every time you played a game, you could lose 2.7 cents on average, would you keep playing? Most people wouldn't, but millions of people willingly play that exact game every single day. That game is roulette. And the reason casinos always win isn't luck, it's mathematics. Here is a secret most players never think about. Every time you place a bet, the game is structured so that on average you lose 2.7%. That number sounds small, but small percentages repeated thousands of times become powerful. And casinos rely on repetition. European roulette has 37 numbers, numbers 1 through 36, and a single zero. If you bet on one number, your probability of winning is 1 divided by 37. That equals 0.027 or 2.7%, which means 97.3% of the time you lose. Already the odds are not in your favor. Now let's imagine a perfectly fair game. If you lose 36 times and win once, the payout should be 36 to 1, but roulette pays 35 to 1. That missing one unit. That casino's edge. It's small, almost invisible, but mathematically it changes everything. Now we introduce the most important concept here, expected value. Expected value simply means what happens on average if I repeat this many times. Here is a calculation. Expected value equals 1 over 37 times 35 minus 36 over 37 times 1. That simplifies to minus 0.7%. So for every dollar you bet, you lose 2.7 cents on average. Not every spin, but over time. Now, let's scale this up. If you play 1000 spins and let bet $1 each time, 1000 multiplied by 0.027 equals $27 expected loss. If you bet $10 per spin, that becomes $270. The more you play, the closer your results must toward that average. This is called the law of large numbers. Short term, anything can happen. Long term, the math wins. Maybe you are thinking, I don't bet single numbers. I bet red or black. There are 18 red numbers, 18 black numbers, and one green zero. The probability of red is 18 divided by 37. That equals 48.6%. It feels like 50-50, but that zero makes a difference. When we calculate expected value, again, we still get negative 2.7%. Even the safe bet is mathematically negative. Now let's talk about the famous Martingale strategy. The idea is very simple. If you lose, you can double your bet and always you will earn $10. Eventually, you will win and recover everything. Start with $10. If you lose, $20. If you lose, $40. It looks manageable at first, but it grows very, very fast. After just 10 consecutive losses, your total required capital is 10 times 2 to the power of 10 minus 1. That equals 10 times 1023, which equals 10,000 to $30. To win $10, this is exponential growth. Your risk explodes. Your reward stays the same. Now, add reality. Casinos set table limits. If the maximum bet is $5,000, you cannot place 500, 1,000, $20. The system stops. And if you lose at that point, you lose everything accumulated. Martingale doesn't fail because of bad luck. It fails because math meets real world limits. Now, combine three facts: negative expected value, limited bankroll, table limits. This creates something called risk of ruin. When you repeatedly play a negative expectation game with limited capital, the probability of eventually losing everything approaches 100%. Not immediately, but eventually. And if you think European roulette is bad, American roulette is worse. It has 38 numbers. Two zeros, the expected value becomes approximately negative 5.26%. The house edge doubles. Casinos don't rely on one player, they rely on volume. Millions of spins, millions of the bets, a fixed mathematical edge. For example, $1 million multiplied by 0.27 equals $27,000 expected profit. Not luck, not cheating, just probability. Roulette feels random, and in the short term it is, but over time, randomness becomes predictable. You can win tonight, but if you keep playing long enough, the math will find you. Because in the end, it's not luck, it's just only mathematics.